All right, students, this video is going to go over section 1.5 in the Math 2 textbook. This is on page 35, and the page you're looking at here is actually the same one as in the student journal. So if you've picked up the student journal, it's kind of nice because it has these problems, but it also has a little more room for you to work out the answers, whereas this doesn't have any room. So if you haven't picked up the student journal, that's totally fine. Just watch the video, follow along. Take a couple notes in your notebook. And if you do have the student journal is yours to keep, and you can write on there. So I'm going to flip over to my student journal. Okay, so the title is Radicals and Rational Exponents. So first off, radicals are the square root symbol. And rational exponents, rational just means a fraction, like 1/2 or 1/3. Okay, rational is a ratio. So 1/2, 1/3, that's how you can write a ratio. And radicals are the square root symbol. The difference is it doesn't have to be a square root. It could be a third root, a fourth root, a fifth root, and that's what we want to sort of go through in this section. Okay, for the first part, we'll mostly talk about third roots here. So, third power, just a reminder, third power means 2 to the third means 2 times 2 times 2. Okay, and that's how you get 8. So the cube root of 8, what it's asking for is asking for what number to the third power equals 8. That's the question they're asking with this statement. Cube root of 8 means what number to the third power equals 8. Okay? Because when you look at this, you might think, well, 8 and 3 don't have anything in common. They don't. But 8 is 2 to the third power. Okay, so there's some common third power numbers that's good to know, like 1 to the third would just be 1, because it's 1 times 1 times 1. 2 to the third, we just said, was 8, because it's 2 times 2 times 2 times 2. 3 to the third is 3 times 3 times 3 is 27. 4 to the third is 64, and they start getting big right away. You'll notice all of a sudden we already, just with 5, we've already passed 100. So if you ever need a list, you can generate these just by doing cubes, and for the larger ones, you'll probably want a calculator. All right, let's take a look at the exploration and see what they're asking for. So it says use a cube root to write the side length of each cube. Now, why cube root? Where does cube root come in here? They don't really say. Let's take a look at this. This is a cube, and that's where we get cube root, but let's not dwell on that. This is a cube, and the volume would be length times width times height, usually. Okay, length, width, and height. Now, sometimes they give you numbers, sometimes they give you variables. Well, here they give us all the same variable, s, s, and s. So length, width, and height are s, s, and s. S, S, S. So what is that? S times S times S is S cubed. And I make my S's a little bit like this so you don't think they're 5s by accident. So the volume is the same as S cubed. Oh, okay. So what that means as far as this goes, these are equivalent. Volume is the same as writing it as S cubed. So you could take that and change this to S cubed. And say that equals 27. Let me write that a little more clearly. You can't really see that. S cubed equals 27. Okay, that's the volume. What we want to know is the side length. Okay, because we want to know which cube is the largest. We can go by volume, or we want to look by side length. Okay, that's what we want to do. Okay, see which one has the largest side length. So if it's third power equals 27, we need to do the third root. Okay, and the third root, here's how it works. The third root cancels the third power, so you just have s. This one would just be equal to s. What's the third root of 27? Again, you're looking for something, 27 written as something to the third. And that something is 3. We've got a bunch of 3's here. But again, third root cancels the third power, and you're left with just the base of 3. Okay, so go ahead and try it out for 125. Set it up the same way. and you're going to need to do the cube root of 125. Now, when we get to something like, I'll leave that for, like I said, leave that for you to do. But when we get to something like this one, 33375, we're going to write volume equals 33375, or S cubed equals 3375. Okay. Now, I don't know what the third root of this is, but we're going to go and set it up. Okay. Now, if this was small enough, we would do a factor tree. This is not small, so I'm going to grab a calculator. Now, it's important to know how to use your calculator. Your calculator has a square root button. Okay, most of them do. This one has, it's hard to see there. So I zoom in. You got the X root. It's the X root right there. So that's how you can put the third root, the fifth root, the 10th root, whatever root you're doing. And the other button just for regular square roots. Alright? So let's do this. If we want the third root of 375, what we do is we press 3 shift and then that button. Okay. So it's the third root of 3375, which is 15. Now, there's no way I would have been able to figure that out in my head. I don't happen to know that 3375 is 15 cubed, and those cancel. So that's how it works. Okay? That is how fractional exponents, or sorry, cubed roots work. All right, on the second part of this, second page of the journal, it has these ones, and again, usually I would do these with the calculator, but this time they want us to estimate. Okay? And then they have a point on the number line, so it's kind of useful. It's kind of useful. The third root of 55, where would it be? It would be somewhere on here. Okay, do we know where it is? Not yet, but we'll figure it out. Here's what we'll do. Let's start with the fourth root of 25. Okay. Now, again, what you're looking for is something that, when it's put to the fourth, will give us 25. I don't know what number that would be. What I'm going to do here is I'm going to make a list. I'm going to go 1 to the fourth equals 2 to the fourth equals 3 to the fourth equals. All right. And at 1 to the fourth, we don't need a calculator. That's 1. 2 to the fourth would be 2 times 2 times 2 times 2. 2 to the fourth would be 2 to the fourth power, or 2 times 2 times 2 times 2 times 2. That's 16. Okay. Again, we're trying to get close to 25. And 3 to the fourth, it turns out, that's 3 times 3 times 3 times 3. That's 81. Okay. Because again, that's 3 times 3 times 3 times 3. That's 9 times 9. That is 81. Okay. So what are we looking for here? We're looking for where would 25 fit in this thing. We're looking for the fourth root. These are all 4 powers, and these are the answers. So where would 25 be? It'd be right around there. Okay. So in other words, 25, the fourth root of 25 would have to be somewhere in between 2 and 3. Okay. Somewhere in between 2 and 3. And you see it right here, down on this number line? The point C is kind of close. So I'd say C is the fourth root of 25. 25, there we go. Okay, I know it's kind of weird how you would estimate that. Again, let's do it for this other one again. Let's see if it make sure this makes sense. And in fact, let me use a separate sheet of paper to make sure we have plenty of room here. So cube root of 65. I don't know what equals 65. What I do need to know is the cube root of 1 is 1. The cube root of 2 is 8. Cube root of 3 is 3 times 3 times 3 is 27. Cube root of 4, sorry, third power of 4 is 64. Third power of 5 is 125, and we've already well passed it. Okay, so we're looking for the third root of 65. We're looking for something that would give us a 65. What number in this list would give us a 65? Well, 65 would be really close to here. Just right past 64. So what it is it must be something really close to 4. Okay, again, 4 to the third is 64. What we're asking is, what to the third, what number to the third power equals 65. And there's not an answer for that. There's not a whole number answer. 64 is really close. This will be a little more than 64. So the answer is a little more than 4. Little more than 4. And again, you can verify this on the calculator, but sometimes it's good to be able to just sort of practice check it. 3 shift 65. And that's what we get, 4.02. So we're pretty close. Okay, so that's how you sort of want to do these things. Alright. How can you write and calculate the nth root? So nth root, what the heck does that mean? What I mean is, if it's a fifth root, that's what we call the index. That is the index. So if it's the fifth root, 5 is the index. If it's the third root, 3 is the index. And when it's the square root, we don't write it, but 2 is the index. Okay, so that's called the index, and if they want a fifth root, that tells you the index you're using on the calculator. Okay, the last problem here says the body mass in kilograms of a dinosaur that walked on 2 feet can be modeled by blah. Here's the key thing. The mass is the m, okay? C is the circumference. So no matter how bad this looks, you're only ever solving for one variable at a time. Okay, anywhere in this book, even if they give you 5 variables, they'll have to give you values for 4 of them. So even though we have m and c here, they do give us the mass was 4,000. So we're going to plug that in. Okay, so a lot of this is knowing where to plug it in. The other thing of this is being okay when it doesn't look like whole numbers. Alright, this is a little bit weird. 4,000 divided by, so what the heck are you going to do? Well, if you remember the order of operations, PEMDAS, we got to work backwards. Okay, so there's no addition or subtraction. Got that done. There is multiplication, though. Before we get to this exponent, we got to take care of this multiplication. So we use division to undo multiplication. 0.00016. Those will cancel, and then we'll get, looks like that gives us 25 million. We got 4,000 divided by 0.00016. Again, make sure you wrote that correctly. Did I say 25? 25 million. 25 million. 25 with 6 zeros. Now, here's the weird thing. Can you have a decimal exponent? Yes. It turns out it can. Now, if this was c squared, we use square root. Well, it's not c squared. It's c to the 2.73, which is weird. But what that is that will be our index of our radical. Okay, so again, there's no way I can, this part I can do in my head. That cancels. 2.73 cancels 2.73. You just have C. But 2.73 power root of a 25 million, yeah, I don't know how to do that. So I'm going to put 2.73 root of 25, 1, 2, 3, 4, 5, 6, should give you about 512.7. All right. So for some of these, we definitely need a calculator. It's good to have. And again, you'll see these a lot in scientific notation, so it's good to know them. The better you know them now, the easier it'll be later. Okay. The final thing is, really, you want to have a calculator that does these functions. You don't need an expensive one. These should be less than $15. It's the Casio. That's a good brand. There's a Texas Instruments one that's good. But you want to look for some of these buttons that you use a lot in class. All right. But don't buy a really expensive calculator, because sometimes it's for accountants and tax people. It'll have buttons we'll never use in our math classes, but they're good to know. So thanks for watching, and make sure to ask questions in class.